All right, last of the videos, number 31 through 40. Let's get started. Number 31, what are the asymptotes? Horizontal is always going to be y equals, vertical is always going to be x equals. So the vertical is going to be x equals, oh, I got to zoom in on that again. X equals, this is 4, 1, 2, 3, 4, x equals 1. And then the horizontal will be y equals 1, 2, 3. So this is where x equals 1, that's vertical. And the horizontal will be y equals 3. Okay, find the vertical asymptote for f of x equals 4 over x minus 4. Well, anytime that you have a restriction on the denominator, remember this restriction is going to be the opposite of that. So restriction is equal to 4. Then if you can't cross it out or simplify it, that restriction is going to be your vertical asymptote. So it's going to be x equals 4. Now we can graph that and visualize what that's going to look like on Desmos. So let's go ahead and do that real quick. You say f of x equals 4 over x minus 4. And when we look at the graph, you can hopefully tell that, and if you plug in x equals 4, you can see a vertical line where that graph tries to avoid touching. It acts really weird when it goes up here, goes down there, and it's just trying to avoid it. So x equals 4 is going to be right, and of course if you move that around, 0, that's not going to work. That's going right through it. And the negative 4, that's all the way over there. So 4 is going to be right here. Okay, solve the rational equation for x. Well, we're going to check our answer right in here first. So we'll say 8 divided by x, right arrow, plus 3. And we'll say fraction bar, x plus 8 over x minus 4. And we're going to look for some values where they intersect. So I see negative 2 and positive 8. So that's how you get that from a graph, negative 2 and positive 8. Just find where those two graphs meet, and it's going to be your answer. Now you can solve that by hand with some LCD methods if you'd like. Here's how that's going to work. You're going to take your LCD, x times x minus 4. Cancel out. Rewrite. So that'll be 8 times x minus 4. Let's use a different color. Plus 3x, x minus 4. Nothing cancels out there because this doesn't have a denominator. Equals x times x plus 8. Now this ends up being a quadratic when you work that out. So it's going to be 8x minus 32 plus 3x squared minus 12 equals x squared plus 8x. And if I get that equal to 0, combine like terms, subtract the x squared, subtract the 8x. Oh, that should be an x there. You're going to end up getting 2x squared. Let's see, those cancel out. Minus 12x. And then you have a minus 32 equal to 0. And then you can factor out a 2. So you got x squared minus 6x minus 16 equals 0. And you can factor that. x minus 8, x plus 2, and solve each one of those equal to 0. But you know our graph got that answer faster than that, so you can also do it that way too. All right, your favorite, the word problems. Peter can mow the lawn in 40 minutes. John can mow the lawn in 60 minutes. How long will it take them to mow the lawn together? You got Peter, you got John, you got together. You do 1 over 40 plus 1 over 60 equals 1 over x, because we don't know their both time. So you could do some LCD stuff, 40 times 60 times x. Um, 40's cancel. 60x plus 40x equals 6 times 4 is 24, so 240. And that's going to give you 100. X equals 240. And if you divide that by 100, you're going to get, oh, it's 2400. No wonder. There's 2 zeros there. So you're going to get 24. And so it'll be that one. And you can do that as a graph. You'd say 1 over 40 plus 1 over 60. Make sure you say y equals, since we don't have a variable x to plug in. And then you do 1 over x. And we're going to see where those graphs intersect. Right there at 24. I know it's kind of hard to see here, but if you zoom in a little bit, you can see. Well, you can't really see, but they only cross each other at 24. Ever so slightly, the green graph goes above it here, but that is their point of intersection. There we go. All right, number 35. In the graph above, which root has a multiplicity of 2? Multiplicity of 2, those are going to be where it has a double root, where it has a minimum to a maximum, or it could look like that. But this is going to be the point right there, and that looks like it's going to be a -3. Let me make that bigger so I can verify. -3 is going to be your double root. These are single, this is a single root here. That's actually a triple root. That's a single, that's a double, that's a triple root at 4. So -3. All right, which is not true. One-to-one functions must pass both the horizontal and vertical line test. That is true. For a function to be one-to-one, you got to be able to do a vertical and horizontal line through those. And if it only hits one point, it's a one-to-one function. So that's a true. Function that's an inverse reflective of the line y equals x. That is also true. The line y equals x is always going to make a function in an inverse line of reflection. So that's true. All inverses are functions. Well, that's not necessarily true, because if you did a reflection over y equals x, and let's say you have a parabola. So let's say I have this parabola here. Now that's a function, but its inverse would look like this. And that fails the vertical line test. So that's not a function there. So that means that this parabola is not one-to-one because you can't put a horizontal line through it because when you do the inverse, that horizontal line becomes vertical line. So all inverses are not functions, not all of them. And the last one, to get an inverse, you switch the x and the y values. And that's, of course, true. The x and the y value switch, that's the definition of inverses. So it's going to be all inverses are functions. That is not true. All right, which polynomial is the product of 3x minus 2 times 4x squared minus 5x plus 8? We're going to multiply together. So I'll just do a little box method, I guess. Get that multiplied. Got 3x, negative 2, 4x squared, negative 5x, and 8. So that's 4 times 3 is 12x cubed. 4 times negative 2 is negative 8x squared. 3 times negative 5x, negative 15x. And negative 2 times negative 5x is positive 10x. But it has a squared. And 3x times 8 is 24x. And 8 times negative 2 is negative 16. So it's going to be 12x cubed minus 15x squared plus 24x, and then negative 8x squared plus 10x minus 16, and those combine to 15 and 8 is 23, so negative 23x squared, and these combine to 34x. And that should give you that one right there. All right, which rational expression is equivalent to 2 over x plus 4 plus 5 over x minus 5? What you want to do here is borrow and steal denominators. So we're going to take the x minus 5 and bring it over here. Copy it to the top. We're going to take the x plus 4, do the same thing. And we're going to distribute that 2. So that's going to be 2x minus 10 plus 5x plus 20 over your denominator, which is x minus 5, x minus 4, or x plus 4. So if you combine these, that's going to be 5x and 2x, that's 7x. And negative 10 and 20 is 10. So 7x plus 10. All right, this one, which rational expression is equivalent to x plus 3 over x minus 5 divided by x plus 7, x plus 3 over 4, x plus 7. Keep, change, flip. Keep, change to times and flip. So that's going to be x plus 3, I'll go ahead and use parentheses, over x minus 5 times 4, x plus 7. We're going to flip that. And this is nice and factored, so we can just cancel things out. We got an x plus 3 there, x plus 7, and I have nothing else. I got a x minus 5 on the denominator and 4 on the top. That's going to give me that. Cool. One more. All right, our last one. This is a rational expression where we have to factor it. So You can get your zeros and switch the signs to get your factors if you want. This is I'm going to do this one just by hand. So what multiplies to negative 15 and adds to negative 2? Um, 15 is 5 and 3. And if I make the 5 negative, that'll work. So my factor is x minus 5, x plus 3. That's for this one here. This one is x minus 5. That doesn't factor. This 8 doesn't factor. This one is 10, parentheses, x plus 3. So that's a GCF. So we're going to rewrite that as x minus 5, x plus 3, then we got 8 over x minus 5, and 10, x plus 3. So let's cancel stuff out. X minus 5s are gone. X plus 3s are gone. And all I have left is the two numbers, 8 over 10. Now, I don't have that as an answer, but 8 over 10, 8 and 10 are both divisible by 2. So that actually divides, and that gives you 4 over 5. Both of those are going to be 0.8, whether you have 8 over 10 or 4 over 5. So same decimal, equivalent to itself. 4 over 5 is your answer. And look at that. Now 1. I'm 1 out of 21. Can you beat me? Try again and see if you can.